Hello students, welcome to today's session on software engineering. In this software engineering lecture, we will be particularly dealing with the principles of software requirements analysis. And this is in continuation of my earlier lecture on the same topic. Most probably today's lecture will be the last part in this series. One very important thing which I would like to stress once again is that requirements analysis is the first step and most important step, and if anything goes wrong in this step, then you can say that the ultimate product may be defective and whatever money and effort spent may become futile. What I will do is that to start with, I will be very quickly reviewing whatever we discussed in the last lecture in this particular topic. Then we will be taking up the new topics that we will be handling today. So we understood the objectives last time, understand the significance of requirement analysis, develop the SRS, know various tools and techniques used for requirements analysis. And then we discussed about what is meant by the requirement, then what is meant by requirements analysis. Then we have discussed about the identification of further requirements during the analysis of mentioned requirements. Okay, then different processes that are involved in requirements engineering were discussed. Then the types of requirements were also discussed. And one very important document that will be developed as output of this particular requirements analysis activity is software requirement specification. This is very important document, and based on the size of the project, this particular document will be running into many pages, sometimes into hundreds of pages also. So this is very important document, and this is the document that will also form a base for developing the test cases to test the software that was built or that is being built. So this is a very much important document, SRS, and what are inclusions in this SRS were also discussed. Then SRS outline was also discussed. Okay, in this we have discussed various sections. The first section is introduction, the second one is overall description, the third one is software requirements, the fourth one is supporting information. Then there are some problems associated with SRS for the simple reason that based on the inherent quality of a particular project, sometimes SRS may not be complete in the first step itself. And moreover, it is not uncommon that when the software is being developed, the development work, and on the way there was an increment announced and you have to make some changes to your software, and suppose a new pay commission had come, then you have to make the software modification. So the requirements may change even while software is being developed. So since there may be new requirements, it will be very difficult to come up with a software requirement specification document as the first step itself. And in the cases of some projects, this particular document is continuously updated. Maybe some requirements will be added, some requirements will be updated, some requirements may be even deleted. And there are many tools in requirements gathering. For requirements gathering, you can use any of these tools based on the project and availability. Like in some cases, you don't need to consult anybody. You have a software, you have to develop another piece of software which is same as this software, except that you will be using the latest tools. Those projects are different types of projects. Okay, so based on the project, you will be using the particular tool or maybe more than one tool. Then how to model the system architecture was also discussed last time. Modeling techniques were also discussed. Elementary modeling techniques were also discussed, and environmental model of an educational system was also explained. Then there are many tools for the environmental model. These tools were also discussed in the last lecture. And finally, in the last lecture, we have gone through the behavioral model of the system. The behavioral model of the system will describe operational behavior of the system. It defines the internal functioning of the proposed system and also the interrelationship between various data, and the tools that are used to develop the behavioral model are data flow diagrams, entity relationship diagrams, data dictionary, and process specification. Today, the first topic that we will be discussing will be data flow diagrams. This is a very, very important concept for the simple reason that ultimately when you are developing software, there is a data associated with it. From where the birth of data is going to take place, in what way it is going to get transformed through the project, and ultimately what is going to be the information that we get from this particular data after applying the software that is particularly part of your particular project. So a data flow diagram, it is a graphical representation of flow of data through a system. It pictures a system as a network of functional processes. There are different levels in data flow diagrams. Based on the size of the project, complexity of the project, processes involved in the project, the levels of data flow diagrams will vary. But still, there is a 0 level or a context level data flow diagram about which we will be discussing. You can see the data flow diagram on the screen now. It's an example. Here you can see the processes. The processes are in the form of ellipses. Okay, and for them you have input data from external entities. External entities means external sources. And again, you will have output data to an external entity. That is, the process is receiving input, the process is giving output. And at the same time, there is also some data which is going to be further processed. Okay, so in your system, what is happening is that it is taking some input data. That input data is processed, and the next step in the processing is activated, and whatever is the output of the processed data is also again transmitted to the external entity or the output device. So you might be having output, you may also have processing in parallel. So it is not that you will get the entire output in one go, or it is not that you will keep on processing multiple times. It all depends on the requirement. So if you look at this particular data flow diagram, here you can see there is a level 1 processing. Then some data from level 1 processing is going to the next level, that is level 2 processing, and again some data from level 2 processing is going to level 3 processing. Okay, and ultimately after 3 processing levels, the data is getting output to the external entity. So what we would like to observe here is that the data that is input may be processed multiple times based on the requirement, and during this processing we may read additional data, or we may transmit the data as output, or we may even save the data internally to reuse it while it is being processed again. Now this is the context level or 0 level data flow diagram. Let me say there is a project, you can say that a student information system. Okay, now student information system project, if you want to draw data flow diagrams, the first data flow diagram will be the context level or 0 level data flow diagram. So in this, what happens is that in the place of process A here, you have student information system, then you will have some inputs, then you will have output. This is the 0 level. So there will be a 0 level DFD for every project. However, as you move, you may have multiple DFDs, and how many levels of DFDs you have, it depends on the project. So context level or 0 level data flow diagrams are one and the same. They are synonyms and they are simple. You don't get any information from it. By looking at it, it is by default the data flow diagram for every piece of software that is going to be developed. Then there are different symbols that we use in a data flow diagram. So there are different notations for it. So these notations are shown here. For data flow, you can see an arrow there, that is the symbol for it, and it represents the connectivity between various processes. Then another symbol is process. Here you can see a circle, or sometimes we even operate as an ellipse. It performs some processing of input data. Then we have external entity. This is the entity where you will be putting the data, or from where you will be fetching the data. So it is the source or destination of system data. The entity which receives or supplies information. Then we have data store. Data store is database. Okay, it is repository of data. So these are 4 different symbols that are used in a data flow diagram. Now, once you are drawing a data flow diagram, don't assume that it is correct. There are several rules that a data flow diagram should comply to. Normally, what happens is that draw a data flow diagram for student information system, make necessary assumptions. This is a famous question. Okay, I mean the format of the question. What happens is that you draw data flow diagrams. When I say data flow diagram, what happens is that you are using different symbols. You have drawn the level 0 or context level, then you have gone to level 1, level 2, level 3, something like that. And then you assume that they are correct. But however, it is not that you draw a diagram that contains those symbols and say that it is a data flow diagram. That is not the case. If some diagram needs to be qualified as a data flow diagram, then it needs to also comply some rules. Only if that particular diagram is in accordance with the rules, then only we can say that it is a data flow diagram. So keep a note of all the processes and external entities and give unique names to them, and also identify the interaction between them. Do numbering of the processes, because the processing units may be many. The data flow diagram should be internally consistent, because anything you are using in a data flow diagram, particular words meaning will not change, and you should not use a different word for the same thing, assuming that this is another processing unit. Many of the things in a data flow diagram are tracked or traced using the labels. Every process should have at least one input and one output. This is a very important point. Now, what is not visible in a DFD? The assumptions about the system. Looking at the data flow diagram, you do not know what we are assuming. Okay. Basically, the data flow diagram will map the entire existing system. Then we can always change through data flow diagram about what we want the system that software is going to make should look like. Normally, people don't want change. Okay. So whatever system they are already following, they want it to be automated. That is, they want to move it to the software enablement. So what is not visible in DFDs are assumptions about the system, the data types, constraints such as processing speed, storage capacity, network features, operating system used. These are not available in a data flow diagram. Frankly speaking, what I would like to say is that this is all part of requirements analysis. So here, technical aspects will not come into the picture. The technical aspects are what type of data you are using. All those things are the jobs of programmers, but still you will have some coding conventions that are being followed by that particular organization, due to which you will be following the same coding conventions in this project also, and sometimes that may lead to the loss of freedom to you who is developing software for it. One very important concept is data dictionary. In one line, the definition of data dictionary is data about data. That's it. You have a piece of data, and the properties of that data may be called data dictionary. A very famous definition of data dictionary is that data about data. So it is a structured repository that stores a description of data elements, attribute, the size, names of related data items, a range of values, data structure definitions, and other things, including details and definitions of data flows, data stores, data stored in data stores, and processes aiming to improve communication between analysts and users. Basically, where data dictionary will be used. Number one, when you are writing very small programs, you don't have a data dictionary. Because when you open the program, when you look at any data item, it is very clear that what is the purpose of that data item, what are its properties, and what it is basically holding. They are very clear. But suppose you are having a mega project, okay, where hundreds of team members are involved and collectively they complete the project. Now there what happens is that when anybody looks at the code, they should understand exactly what is happening, what is being used for what, everything. So there the data dictionary is very useful, and each and every one of you is preparing for a career where you will be handling very, very big and huge projects, not programs of size which you write in today's class. Okay, these are only practice problems. You will be doing your project and then you will be joining some organization where you will be doing big projects, and ultimately you may land at a place where you get some mega projects, and maybe your role will be to be the lead for the entire team. Okay, so data dictionary and all these concepts are very, very important, and they are very useful for those people who are handling big projects. So there are many advantages of a data dictionary. Now let us take one example, data dictionary of a payroll processing system. In that you have a data item, employee name. So basically employee name means you may write your name, that's it, but it is having two parts, first name and last name. Then you have an employee ID number, then you have an employee address. And again, when I say employee address, it's not that you type some 4 to 5 phrases or words, and it includes everything. For example, let me say I want to look at all those students who are from a particular pin code. Okay. Now, if we are putting the entire data against one field, then I will not be able to track. Okay. So I have to split it. The address part should be split in such a way that I should be in a position to print a mailing label or to get information about a particular area or a pin code, many things. So to the extent possible, the data should be discrete as well as meaningful. Then you have the basic salary and the additional allowances such as perks on basic pay. So this is one example of data dictionary of payroll. This is the name of the table or an entity in which you have employee name, employee ID number, employee address, basic salary, and additional allowances are the fields. Now comes entity relationship diagram. Whenever you are doing a project, first diagram that comes is data flow diagram. Then comes is entity relationship diagram. I am speaking about the hierarchy among the DFDs and ERDs. Among DFDs and ERDs, the first one is DFD, the second one is ERD. So an entity relationship diagram is a detailed logical representation of data for an organization. It is a data-oriented model of a system, whereas DFD is process-oriented model. It represents the data at rest, while data flow diagram tracks the motion of the data. An entity relationship diagram does not provide any information regarding the functionality of the data. Every project will also have an entity relationship diagram wherever there is a database. In those projects where there is no database, then it all depends. You may or may not have an entity relationship diagram. Now let us see what are the main components of the entity relationship diagram. One is data entities, the other is relationships, the other is associated attributes. So you have an entity, then there is another entity. The connection between these entities is termed as the relationship. There are different types of relationships: one to one, one to many, many to one, many to many. Okay. Then we have generalization and many things which we will be discussing. And apart from having entities and the relationships between them, every entity is also having some attributes. What are these attributes? The attributes are nothing but fields. For example, consider the payroll entity. It is having an employee ID. It is an attribute. Employee name is an attribute. Like that, every entity is having some attributes also. So let us see the types of relationships that are possible between two entities. The first one is symbol, for which it is the mandatory one, cardinality. So the cardinality is 1 in this particular case. If you look at the first symbol, the relationship represents a cardinality of 1. Now in the case of second symbol, it is many m, in the sense that in the case of first one, the cardinality is 1. In the case of second one, the cardinality is n. Okay, this n is greater than 1, and it is the highest range that is possible for that particular project. The third one is optional 0 or 1 cardinality. So when you have a symbol of this type, we say that the cardinality is either 0 or 1. Then the final one is you have 0 to many relationship. Okay. So here you have optional, 0, many, cardinality. So these are the relationship cardinalities that are possible. Now let us take another entity, student. So here we have given the student entity and see the attributes: father's name, roll number of the student, the address of the student, the class in which student is studying, and the marks is secured. These are the attributes of the student. So you consider any student, that particular student is having all these attributes. So this is one example of the attributes of entity student. Now let us see what are structured requirements definition. SRD, which stands for structured requirements definition, it is an approach to perform the study about the complete system and its various subsystems. Structured requirements definition, it is an approach to perform study about the complete system and its various subsystems. The external inputs and outputs, functionality of the complete system and its various subsystems. Now there are various steps in structured requirements definition. They are: make a user level data flow diagram, create combined user level data flow diagram, and generate application level data flow diagram, and also define various functionalities. So as part of the requirements analysis, we should also develop the structured requirements definition. So the different steps are important, because the first one is we need to develop a user level data flow diagram. For example, if you take a student information system, when the student visits a university, or how the student interfaces with the university is very important. Let me say, when a student visits a university, there itself you have the first process, that is the reception. Okay, as your data flow started, the student first travel to the reception, then the student is directed to a place based on the problem the student is having, or based on the request the student is carrying for the university. So automatically what happens is that from that particular process, again you have multiple processes based on the requirement. So make a user level data flow diagram. This may not be easy. Okay, the data flow diagram itself may consume a lot of time in a very big project. Then you have to create a combined user level data flow diagram, then generate application level data flow diagram, and we have to define the various functionalities, because everything should go hand in hand. You have a data flow diagram and you should also describe it separately. So when somebody looks at the data flow diagram, they know that the data is moving from point number 1 to point number 2. And why it is moving from point number 1 to point number 2? We have to write text to support it. And what is the objective of it? The objective is not only to make the software that is going to be finally built or deployed to work perfectly, but also for anybody else who is not involved in the project to understand the project, so that in future a new requirement comes, then they should be in a position to update it by understanding the logic. Or a new technology might have come and the software needs to be ported to the new technology. Then also one needs to understand the software. That is the reason why we have a lot of things. What I suggest is that most of you must be writing programs directly onto the computer. You may be entering the computer lab and start typing the program and run it and find that there are many errors, and error by error you go and you rectify them, and ultimately you successfully compile and then execute. But that is a wrong process. First of all, you have to write on a piece of paper the steps of the solution for that problem, which is called an algorithm, and then only you have to translate each step of your algorithm into the corresponding programming language. This is about smaller programs. Now suppose you are doing a mini project, then your data flow diagrams, everything comes into the picture. Now, one very important thing is that you carry entire paperwork and your program to your friend and ask him that, can you please explain it to me? If they are able to successfully explain, it means that you developed the software in a very systematic manner. In case you are unable to explain it properly, I mean, in case your friend is unable to explain it to you properly, then it means that there is some problem with your documentation or software and you need to take care of it. So there are different steps in this software requirements definition or structured requirements definition, and we have to fulfill all of them. And what we will be doing is that in the next class, we will be handling prototyping and other things. Here in today's lecture, we will stop here. Okay, here we have seen the data flow diagrams, entity relationship diagrams, structured requirements definition, and other things. Okay, in the future sessions, we will be handling the remaining topics. In case you have any doubts, you can always email to me. My email address is pvsuresh@ignou.ac.in. Thanks a lot.